And for everyone today, we have Michel with us, whom I had a pleasure of meeting in Paris New Crafts conference, right? And it was really awesome to attend like this 15-minute corridor exercise with him on a very similar subject, flow and productivity, right? And since then, Michelle, I've done it at least a dozen times. So I literally took your
Mm,
idea and think of it as either am I spreading it or plagiarizing it, but I'm doing one of those for sure. And I've done it at least a dozen times. I'm so sorry for flooding your Heroku instances. I've been using your Heroku instance as well from past couple of months. Um, but you won't believe it, right? We have had product analysts, developers, even our operations and HR team has attended this training. And this small workshop, but they have found it like really incredibly powerful, right? And they've started applying it wherever they can. Uh, and I definitely see a lot of value to discuss similar topics with broader scope and broader audience, right? So it's uh, definitely something that should not be contained to one company or one conference. And that's why we have brought you to our crafters community in India. We have a slide for that as well. Also, if you want to switch to our software crafts people community, it's sponsored by Incubite, where I'm the co-founder. Incubite is team of crafters, and we build software products for our clients with a focus on XP practices and craftsmanship mindset. Uh, that being said, the floor is all yours, the digital
right.
floor.
I'll start by sharing my screen. And I always have to watch to not hit the leave button because it's next to share and it's much bigger. Um, so now I understand why my logs always said there's someone using this system, and I didn't know who it was.
Hey,
Right.
and that's being said, Michelle, we would love to in any way support either the open source development for the board or in any way if we could support hosting Heroku plans. And please, you feel free to send me a note after, or we can talk about it after the
All right.
this talk.
Cool. I don't think it's necessary because the cost is like almost nothing. So welcome to my short talk about flow in general, and I'd like to just explain what I mean with flow, and I'm going to do that with an animation. I'm not sure if you've seen this before, but this is like a very simple simulation of traffic, and you see like everything is flowing like it should be flowing, and you can see this as a metaphor for our software development practices. So ideas come in at the top here, and then they flow in, and some analysis gets done. There's architecture, and then on the workflow we work here, and then we release everything to production. And as you can see, something happens at the workflow right now. There's a traffic jam appearing there, but up here, management doesn't know it yet. So the product owner is not even realizing there's a problem, and then all of a sudden traffic heaps up, and there's like this big ball of traffic, and now there's big meetings. We need to work faster, we need to improve our productivity and things like that. And the reality is this system will never be solved. You cannot solve this problem by just working harder. There are other things you can do, but the levers are not just cracking the whip and making people work harder. Um, Adding people to the system might solve it if you're adding the right kind of people at the bottleneck, but otherwise it will be completely useless. And that is what I'm going to try and illustrate in my game and my simulation that's coming up. I leave this tab open so we can refer to it later on. The traffic will never be solved. I can guarantee it. So, oh, not you. What are we going to do now? We're going to play. And so that means some of you are going to participate in this game, but I'll show you just what it's going to be about. We're going to have like this board here where someone is going to be responsible for the to-do column, adding tasks to it. Someone is going to do some small analysis, someone else going to do development. There's going to be an ops person and the QA that's going to validate, do I accept the story or do I reject it? And so let's zoom in. The person creating the task is just going to hit a button and tasks are going to get created. And so these tasks will appear on the board here and analysis will get these tasks in their inbox. And so let's take one and there's like this number that I have to copy. Go, I copy it, I click OK. And on the board, it moved one column extra. So now we go to development. Development starts something, has to calculate 55 minus 3. That would be 52. Please correct me if I'm wrong. Too late. I just clicked it. Then there's going to be ops who gets that task 7 times 4, which would be 1428. There you go. And then at the end of the line, QA is going to receive that message and see the 3 things that were solved and accept or reject it. So QA is going to know, given by the system, if the tasks were executed correctly. Right, this is in a nutshell what we're going to play. 5 people are going to do this work. And the thing I'd like to start with is, could you give me some estimates about the work we're going to do here? So shout it out in the meeting chat. I'd like to know what you think the time will be to finish one story. So a story enters the board until it's finished. How long do you think it will take in seconds? I'm watching the chat. 5 seconds. Okay. I see 20 seconds. 45 seconds. Okay. I don't see anything wildly out of range of these estimates. So just to make sure, if we say 5 seconds, this means copying a number, doing a small calculation, a second small calculation added together would take about 5 seconds, 20 seconds, or 45 seconds. And then, of course, rejecting or approving it. So this is what we call lead time. So the time it takes from a story from the beginning until the end of the board, what is on average the time it takes to do that? And then there's a second estimation I'm interested in, and that's how many of these stories do I do per minute? So I'm going to go back to my documents here, and there's a second estimate I'm interested in. Number of stories done in 1 minute. So this is just a number. Shout out in the chats. I see 2, I see 12 per minute, 3 and 6. Let's take something like that. Okay. Nothing wildly out of range of these estimates, right? So just a small remark. These numbers are already widely out of range from each other, right? 5 and 45, it's very far from each other, and 2 and 12 also. This is what we call throughput. Typically, for example, in Scrum, we tend to measure velocity, which is kind of a throughput measurement. Small detail, velocity is never mentioned in the Scrum guide. So it has been added by the industry, but it was never in Scrum by default. So we've got our estimates. We'll come back to those later. We're now actually going to play a game, and I'll invite you to scan this QR code if you want to participate. We've got a product owner. Analysis is filled in. You cannot do anything yet, so you're just registering right now. Development, ops, and we still need someone doing QA. Then there you go. Oh, analysis. Oh, we have a conflict on QA. We have too many QA people. Could some of you drop off? Yeah, there's a slight delay in in the system, which makes WebSocket not really work as I wanted to. So we don't have anyone in development and ops now. Sometimes there's conflicts there. Right, someone from QA is going to have to drop off, but we'll continue like this.
Yep, we just want to make sure not both the QAs drop off as well.
Yes.
Like one.
Yeah, it's hard to coordinate that one. Okay, we have one QA person, but ops is gone. Is that like a phone that went to sleep?
We had ops earlier. It's gone now.
Yeah, ops is gone. Oh, there it is. All right, perfect. Right. So the task right now is you're going to get 2 minutes of work as hard as you can and as fast as you can. That's it. That's the only requirement right now. I hope it is clear. That means that the product owner who's doing the to-do is just going to push that button as much as they can, and everyone is going to solve the problems they have to solve. Right? Let's go. 3, 2, 1, go. And I'm not seeing any tasks appearing. Who has the to-do column? Just a reminder, the one having to do has to hit this button here.
And on the phone, it may look a little bit different, but there's like this blue big create task button. All you have to do is keep clicking on it.
Yes. It's probably going to look like something like this.
This.
Right? No one there? Otherwise, I hit the button. Okay.
I think let's do that, yeah.
Yep. So analysis should be picking this up. QA has got some work to do here. And where is QA? Come on, people.
All right, I think we lost the QA as well.
Yes, and they just reappeared, but this means that we delivered nothing. So we're not going to get any bonuses for this one. I think I'm going to go back to the QR code so that everyone can register here. And on QA side, I don't know what happened here.
I'm getting sorry, the game is full message. Okay.
Right. Let's try it like this. We'll see what happens. We're going to do the same exercise again. Sorry about that. There's 2 people doing development and 2 people in ops. Let's just see what happens. I don't think it's going to be a big problem. Right. Ready to go? Start. And now I hope someone's, oh yeah, there you go. As you can see, we already have 2 defects. So try to focus on having the tasks executed correctly, like simple additions. Mm-hmm. A few more seconds to go. Right, this iteration is done. So what happened here? First of all, when you look at the board, you see that there's a big column just before analysis. There's a smaller number of stories before development, and there's an even smaller before ops. And looking at the board just like this, I would conclude that the bottleneck is analysis. This is wrong, but this is the conclusion I would have just by looking at the board. So you're not really able to look at this or to estimate this. So if I go and back to what are the numbers we have here, so we have a total of 18 things that are done. 3 of those are defects, 15 are successes. We have a work in progress of 84 stories ongoing. We have a throughput of 7.5 stories per minute, which is somewhere between the 6 and the 12. So our estimations are not really off. And our lead time is 11.2. And now the big question is, what's the units? Does anyone have any idea the 11.2? So the thing is, it's 11.2 minutes, the lead time, not seconds. So we estimated 5 seconds, 20 seconds, 45 seconds. It's actually 11 minutes. Why? So let's open the chart here. So this is the rate at which we did some input. Ooh, someone stopped working here. I noticed that now. So this is the rate at which tasks entered the system. And the purple one here at the bottom is the rate at which tasks left the system. So that means that if you stop working, you stop adding things to the inbox, to the to-do column, the moment everything will be done is when that purple line crosses the red line, and that is far off screen right now. Well, I have to point that way for you. And that point is probably going to be about double the lead time. So it's probably going to be 20 minutes in the future. So on average, every task is going to wait 11 minutes between the moment it appears in to-do and the moment it's done. So this has to sink in. The problem we have right now with waiting for solutions in our software industry is because of this lead time that is much too high, because we have too much to do at the same time. So we're going to try to solve this by applying Little's law. And Little's law, I'm going to go a bit further here in one go. This is Little's law. So lead time is work in progress divided by throughput in a stable system. I have to add that every time because the thing we just did was not a stable system. So that means that if you want to reduce the lead time, you'll have to reduce your work in progress. And this is what we're going to do now. So the next iteration, we're going to do the same kind of work. We're going to have the same team. We're just going to have working agreements, how to pass work from one discipline to the other one. And so what we're going to do now is the person adding to do is not allowed to create a task if there's 4 tasks in the outbox. So never more than 4. if you go to analysis, analysis is not allowed to take any tasks in the workspace if there's 4 items in the outbox. Or so the total of workspace and outbox can be maximum of 4. That is, of course, the same for development, a maximum of 4 in the workspace and in the outbox together. Ops, same rule. For QA, of course, you can have a limitless amount of done things. So there's no limit for QA. Is that clear? Yeah, I see some people nodding, but I don't see everyone. So, okay, everyone's still here. No, analysis is gone. Is that phone gone off to sleep? Okay, the analyst is back. Let's do a second iteration, and I want to see the total of each pair of columns, maximum of 4. Right? Go. Oh, on analysis side, watch that you already have 4 things in your workspace and your outbox together. You have too many things right now. Yep, exactly. So on development side, there's also too much going on right now. There's 6 things going on there. There should be 4 maximum. Yes, exactly. So you see how ops is like holding the system back right now? And every time something moves in ops, everything is moving it back again. So you really see this movement of flow happening. Oh, and it's already over, sorry. So the 2 minutes are over. So what happens? Throughput did not change, which is actually a coincidence, but it's a very happy coincidence to me. So in Scrum terms, the velocity did not change, although we limited the work in progress tremendously. So we went from 84 things ongoing at the same time to only 12. And the lead time, and that's where the magic happens, went from 11 minutes to a minute and a half. So this is a dramatic improvement of lead time. And this is the moment where this graph here, the cumulative flow diagram, you can read these things. So the throughput, for example, that's the slope of this purple line here. So the more the slope is elevated, the higher the throughput. The work in progress at any given moment is the distance between this purple line and the red line. So the vertical distance, which is a work in progress. And you can see, for example, that here, the distance was much bigger than here, for example. So we lowered our work in progress. And the lead time of every item you add to the system is just a horizontal distance between the red line and the purple line. So here we had a long lead time because work in progress was high. And once we get here and we cross the purple line that's going to be here somewhere, the lead time is shorter. So by limiting work in progress, you limit the lead time. It's actually visible in this graph. This is only valid in a stable system. So what is a stable system? I'll show you an unstable system first. The previous one had like a different slope of outgoing compared to the incoming things, which means the system is not stable. And this one is stable because you see after a while of initialization here that the slopes are kind of converge and go in the same direction or at the same slope. That is what a stable system is. So we went to 1 minute and a half, which is still far from what we estimated here, right? Here. So right now it's 90 seconds. We double from the worst estimate we had. We're going to try to improve that even more. So
I think
we had it. Yes, go ahead.
Michel, I think there's this one thing, time to complete one story. I think what we mean is average time to complete one story, right? Because we have so
Yes.
many. I think that's what has been throwing me out. Okay, just wanted to
Yes.
clarify that. Yeah.
Yes. So this one is the average time.
Right.
The time you see here on a horizontal scale is the actual time of each and every story. So that story that was put here in the system was delivered at that moment. So
Right.
unless stories caught up from each other. So that's from the idea that things flow sequentially.
I think that's why a few questions that I'm seeing on the right is what about the to-dos? Do we consider to-do as WIP or not? And I think the answer lies in this, that, hey, whatever you are creating, we're calculating the average time. So whatever is in to-do, we are calculating average time based on that, right?
Yes.
Okay,
Right.
perfect.
So
That makes sense. Yeah.
it's not a question of do you count the to-dos with you in the work in progress or not. If we would leave out the to-do column, we start measuring at analysis column. So it's just a question of what is the scope you want to measure and you want to improve. The more you go wide in scope from ID to it's in production, then you're going to optimize the whole system. If you limit it to only your team, starting analysis until it's merged in main, then you're limiting your scope and you're also limiting the effectiveness of what you're trying to improve. So it's always a question of scope, how far can you go? And it can go fractally, right? You can do that within a project. You can do that over multiple projects where every card is one project. Or you can do that on portfolio level where you take the whole company into account. So we're going to do 2 more simulations. We're going to do the work in progress limiting over the whole board. So the person doing the to-do column is going to watch this number here. And that number is going to have to be limited to 8. And so the idea is if we go from 12 to 8, this number should go 2/3 down. That's the theory behind it. We'll see what happens. Is that clear? Okay, let's go. Hit it. Oh. So you can add one more. Yeah, there you are. And now you don't add anything. Oh, until it's 7 and then you add 1. It's 9 right now. Yes, okay, 8. Right. Okay, the product owner understood the problem.
So it's the WIP row, work in progress row that you're monitoring, right?
Yes.
To keep it constant
This one
to
here.
8. Okay.
Yes. Yeah. We had a surprising hiccup where development had nothing to do for a while, and that is a bad thing, but it's gone now. A few seconds left. All right, the iteration is already over. There is a surprising thing that I have never seen in this simulation. Usually the bottleneck is development, but now it's operations. And I don't get why, because these tasks should be easier, but it doesn't matter in the simulation. So what we optimize is we don't look at the details, we optimize the whole thing, and it still works, right? So we went from 12 to 8, and the lead time went down at almost the same rate, unless you look at the throughput, which went down a bit too, but that is accidental. So this 7.5 that we had on both simulations was more an accident than a real than something we changed in our process. Let's look at this one. So we had multiple times that development had nothing to do, and ops is the bottleneck right now. We don't know why, but it's there. So the next part is going to be harder because my assumption was that development was going to be the bottleneck. Okay, we're going to do the last simulation and we're going to apply something called the drum buffer rope. So drum buffer rope, I'm not sure in India if you have marching bands. I suppose you do. And the typical thing is in front of the marching band, there's this stick-bearing women typically that marches in front of everything, and then halfway there's like the person with the big drum on their belly. It goes like boom, boom, and that is typically the slowest in the whole band. And so to not have the whole band stretching out because the front person is faster than the one in the middle, you have to imagine a rope connecting the drum with the person in front, and so that the marching band goes continuously at the same pace. That's what we're going to do. So what the product owner has to do, so the one managing this column, is watch the bottleneck, which accidentally is ops right now, but might become development. We'll see what happens. And the only thing you have to do is add just enough stories to the system so that the bottleneck has 100% of the time work. Right now, this column is too much, right? These things are just waiting. If you could add less items to the system so that there's 1 or 2 items here or there, that would be better. But that you'll have to watch the board and not just the number here. I'm not sure this will improve this current system because it's so far down the line, but we'll see what happens. So the product owner is, and especially you, is it clear what you have to do? And I'm not sure who I have to watch because I don't know who the product owner is. I'm going to assume it's clear. Just add just enough stories so that the bottleneck has work. And there's going to be delay between the moment you push the button and the work arrives at the bottleneck. So you'll have to be playing with, you'll have to play a bit with time. I'm very curious if this is going to work or not. Let's see. I'm going to start. Go.
No, I think, are we creating to-dos too fast, Michel, or?
Excuse me?
I was just wondering if we were creating to-dos too fast. Should we?
Yes. So I'm not creating to-dos, right? It's someone in the audience.
No, someone else is. I thought
Yep.
if you want to prompt them that create now for like first few to-dos.
Because
I saw someone create the to-do creator created 5 to-dos to begin with.
Right now it's going at a right pace. So okay. I typically leave that up to the initiative of the person in that column, and it's going okay right now.
So Michel, what's the guiding principle that you use when to create a to-do in this final iteration?
From the moment you feel development or ops is not going to have enough work. So it's more a feel thing of once something leaves the bottleneck, add something. But right now, it's not clear who the bottleneck is.
Yes. So once something leaves the done column, you add it. You add a new. Yeah.
So right now, ops has nothing to do. If ops was the bottleneck, it would be a problem. But I think right now development is the bottleneck, but I'm not sure. Oh, and the 2 minutes are over. I was staring at the screen. Very sorry about that. So by accident, our throughput went way up. It went to 10. Our work in progress was 5. And so our lead time is half a minute. And so compared to what we predicted here, we are now between these two states. So without changing the work, without changing the team, we improved from a lead time of 11 minutes to half a minute. And the throughput from 7.5 to 10, you have to take my word for it. This has nothing to do with whatever we changed right now. So this was the most optimal, and I'm very happy to see that, the most optimal solution, having this rate controlled by the input. If something's done and the bottleneck has almost no work anymore, add something to the system. This is what we had right now. So I'd like to show this slide again. Let's do it like this. So what we did was push-based work, just work as hard as you can and push to the next column, which increases work in progress tremendously, which of course increases lead time too. Then we did pull-based work where everyone had the limit of 4, which was kind of okay. Then we did a system-wide limit where we said over the whole board, maximum of 8. And then we did the drum buffer rope principle, where you have to feel how much you can add to the system without overloading it. And those were always an improvement on the previous one. And so the thing you always have to keep in mind is Little's law. Lead time is work in progress divided by throughput. So it has no influence by how many people in your team, has no influence, is not influenced by what kind of work you have. This is something that is almost universally applicable. Of course, it's a simplification, but it's a good guideline to follow. So I'd like to speed up things and show you a simulation where we can go much faster than what we did right now. So this simulation, the graphs are kind of the same as in the game we did right now. This is just some developer is working at 50 stories, and we're just looking at the rate of change of everything. But in this simulation right now, every story takes exactly 1 day to complete. So that means that the lead time is 1 day. So every story takes exactly 1 day to complete. And the throughput is 1 story per day, of course, because everything is 1, everything evens out. And I've got 2 graphs here. One that is the cumulative flow diagram that is showing lead times, throughput, and work in progress. And this is more flow metrics where we see the throughput, the lead time, and the work in progress at any given time. And so now it's not very interesting because everything's predictable. I'm just going to slightly change this to every story has an on average completion time of 1 day. And so the effect is now going to be on average, we're going to get the same numbers, but at every given point in time, we don't have the same numbers. So in this graph, for example, you can see Little's law. So the lead time times the throughput is the work in progress. And you see that lead time and and throughput are like mirrors of each other. If lead time goes up, throughput goes down. If throughput goes up, lead time goes down, because work in progress can only be 1. Because there's only 1 developer, and of course, they're a good developer and they do only 1 thing at a time. And so this is also, I'm showing this so you can prime your ideas of how this simulation is actually working. The numbers are the same. So it took 50 days to complete the whole project. Here it's 51, but it's give or take small differences in the variable work. So what I'm going to do now is I'm going to change the work that we're going to have some UX work. That's going to take 2 days. Development is also going to take 2 days on average. And then there's QA, who's also going to take 2 days on average. And the team is 1 UX person, 1 developer, and 1 QA person. And so let's look at what that gives. So we accelerate things so that we don't have to wait so much. And there's 200 stories in the system right now. And as you can see, queues appear between dev and QA now. Now it's between UX and dev, and then it goes away again. That's because there's statistically differences in the probabilities of how much work is done. And every time a queue appears, delays increase. So that means that something on average that should take 6 days to complete actually has a lead time of 12 days. So every item on average waits almost 50% of the time. And that is just a very simple effect of statistical fluctuations between probabilities of how long does a task take. So what I'm going to do now is I'm going to add an imbalance in the work distribution. I'm going to say that UX takes only 1 day, but development takes 3 days. So in total, it's still 6 days to work. But if you run this simulation, of course, the big bottleneck appears before development because they take 3 times as long to finish a story as UX can produce. And so in time, you see everything going up, lead times going up. And now at this point, UX has done its work and they go on to another project or they move to another company. And if there's any feedback on UX right now, there's no one to pick that up. And then you have to go like find someone else to do that. And this increases times again. And it's all problems from here. It's all downhill. And lead times still increase because the item was already in the system and had to wait so much time. So the typical reaction to this problem is, let's add a developer, right? So we're going to do that. We're going to add a developer to the team, which makes the team more expensive. So we increase the costs of the system so that we can catch up. And so now you kind of see 2 bottlenecks appearing, development and QA, where things accumulate. And all of a sudden, again, UX is done. We have the same problem, but development is catching up more quickly and QA is left with the work right now. So if any feedback on development happens now, we have to go and get the developers from other projects and there's again problems. But the lead time improved. It was 200 and it went to 105. So it halved. Seems kind of successful. The throughput also improved from 0.3 stories per day to 0.46, but it didn't quite double like we expected by adding a second developer. But since this worked, let's add another developer to improve the system and see what happens. And so again, we increase the cost of the team and we see that 3 developers are working at the same time on different stories. But something unexpected for the manager who added developer happens. Both are gone now, and again, QA has to fix everything on their own. And what's worse, the numbers haven't changed significantly. So throughput remained the same while we added a developer. Lead time didn't really improve, or almost not, and so time to completion of the project remained the same. So what happened here is we added a developer to the system while development was not a bottleneck. That was not the problem to solve at that moment. So what I want to do now is illustrate how to improve the system by going back to the basics. So we're going to go back to the original team with 1 UXer, 1 developer, 1 QAer, And we're going to do, just like we did in the exercise previously, we're going to limit the work in progress. And we're going to say 10. So now, if the whole system has 10 things between backlog and done, we don't add anything to the system, which makes the UX person wait. So they have like a lot of time, they have nothing to do. So they're working at 36% for the moment. But we just watch the system. So we're not going to judge on the individual performance of the people. We're going to look at the overall performance of the system. And so on the throughput part, we see that it rapidly stabilizes from 0.3, and it's still 0.3 here. But again, lead time was 220 days then, and now it's only 31 days. So we improved the question of when will this task be done? The answer is once we start, within 30 days it will be done. And so to check the relationship lead time, throughput, and work in progress, let's halve the work in progress limit. So you're not allowed to add more than 5 things to the system, and see if it has no effect on throughput and it halves the lead time. So just by running this simulation, I can confirm that by limiting work in progress, you improve the lead time without changing the throughput. And so
Michel,
we'll just wait. Yes, go ahead.
Yeah, while we wait, I'm just wondering which column is the original column when we had one UX, one dev, one QA, but no WIP limit, just to compare.
Oh, that was here.
Okay.
So one UXer, so UX is 1 unit, 1 day, development is 3 days, QA is 2 days, and we have this team.
Okay.
And there was
so
no
that's
WIP,
one
no
UX,
work in
one dev,
progress
and one.
limit. Yes.
Okay.
And back then we had a WIP of 66 on average, but a maximum of 133. While here we now have a maximum of 5. And so these are the two you can compare. So throughput is still remaining the same because we didn't change anything about the work or the team. And lead time improved tremendously here. So it's 220 days compared to 16 days to finish a single task or a single story. So what we're going to do now is we're going to cross-skill. We're going to say, one of you, if you have nothing to do, please go and help someone else. And the one I'm going to pick now is the one downstream, because that's the easiest to me. I'm going to say to a QA person, if you have nothing to do, please go and help development. So the assumption underlying this is, in the beginning, a QA person will not have the same level of proficiency as a developer, but we're going to skip to the moment where they have the same proficiency. So there is kind of a delay there. There is a learning curve you have to go through, but we're going to look at what is the effect if a person can choose to do QA or development depending on the load. So we're going to run this. Yes, go ahead.
I think, Michel, you can run and I can ask you a question. So while we're waiting.
Yeah. Yes.
I think
so just notice that sometimes two people are working here. That's it. Go ahead, Sapan.
When you said this, did you take into account that dev has a queue? That's why did you write QA plus dev, or like did you use any logic in terms of who helps who over here when you select a QA plus
Yes. Dev? So there is one person in the team that can do QA and development, but their main task is QA. So if there's work for QA, they will do QA. At the moment they have nothing to do, they go and help on development. And once they've done one task of development, they look at their own inbox. If there's something there, they go back to QA. So the effect right now is our throughput went up from 0.3 to 0.37, which translates in the project took 659 days previously, and now it's 541 days. So there's 100 days, more than 100 days that we spared, that we saved here. That is the effect of cross-skilling your people. The work in progress was the same, lead time was even slightly improved. So since this worked, let's apply that to UX. let's not make the leap that UX can do development, but they could be helping in QA. So let's do that. Let's make, if UX has nothing to do, please go and help QA. And there you go. Sometimes there's 2 people working here. And that is if the inbox of the QA is big enough. And there is nothing to do here because too much downstream going on. And you can see that the numbers stabilize quite quickly. We improved our throughput. Our lead time went down again. And the work in progress on average went down, which is actually a surprise. We limited it to 5, but it never went up to 5. Or maximally went up to 5, but on average it wasn't on 5. And our project time again went down. And so now I'd like to add the ideal state that you're never going to reach. That is, everyone in the team can do anything. So the asymptotically full stack person, right? We have 3 full stack people. Oops, full stack. And we work like this. So the effect, of course, is the person does UX, puts it in the outbox, and then sees, oh, there's something development to do. And they pick up their own output every time, which, of course, on a quality level is a problem. So we don't want this. But on the flow level, this is the ideal state. Notice work in progress was with rounding errors 3 all the time. Project time has improved again. Everyone was working as much as they can. Throughput 0.46, which is the best that we had, even here with a very expensive team. And lead time only now is very close to the actual work time that is the thing you have to do. So the actual work is 6 days of work, and our lead time was a bit more than that. It's 6.4. Only now can you actually trust the estimates you're giving on the time it takes to finish something. So this is at the same time a presentation where I want to show you that limiting work in progress is effective, cross-skilling is effective, and estimates don't work unless you have a very smooth flow in your teams. So let's go a bit further here. Key learning takeaways, cost of queues, cycle time goes up. If cycle times goes up, everything is slower. Risk goes up. So if you have something in a queue that has already some assumptions baked in, but at the end of the done column, you only validate whatever you've been doing, it costs a lot to fix that down the line. Technology changes in direction you want to go, whatever you want to change in the system. Variability goes up. I didn't show that, by the way, but variability in the sense of if this load changes from, let's say, this is 3, this is 1, and this is 2, we will end up with the same flow numbers. So it doesn't matter how the distribution of work is. If you have a stable flow-based organization, your speed is not going to change. Right, so it stabilizes very quickly to the same numbers for throughput and lead time and work in progress. Oh, come on. We were here. Costs go up, of course. The more you have projects that are in parallel, the more you have to report these things, the more people are worrying, what's the status right now? And then extra people get hired to manage state and so on. And quality goes down because you have delayed feedback. I make something right now, but I only know that it actually works when it's done, and then only do I get feedback of my work. Not only that, but the feedback of the things that are downstream in my process is also much quicker. And I think I'm at the end of my, oh yeah, okay, right. There's also quality. The pressure of having this big inbox as a developer of things you have to do is also something that encourages you to go faster and maybe improves the probability of taking shortcuts, which in the long terms will take longer to fix. So, work in progress throttling is essentially free. It's just setting a limit and things will go better, improves lead time, makes bottleneck visible, creates slack for non-bottleneck skills where you can go and improve process or improve whatever you want. But always keep the bottleneck running at 100%, because if the bottleneck slows down, everything slows down. Then cross-skilling is cheap. It's not as expensive as we think, but of course there's a learning curve. And then adding people is the most expensive thing you can do to improve your speed. And also, estimates are not correlated to lead time, right? And I think that ends my presentation. And I think, yes, useful links. I'll share the PDF of this presentation so you can play around with those things at your own speed. And we're on the hour. Wow, I'm happy. So if there are any questions, feedback, or whatever, this is the moment where you can go to your meetings if you have anything planned. Otherwise, I'm open to questions.
I see Sia has a question. Yeah, go ahead, Sia.
Thanks, Apan. Hi, Michelle. So I think throughout the exercise, we tried two approaches, right? First, we tried to throttle the work in progress, which had a positive impact on lead time, but everything else more or less remained the same. And the second thing we did was cross-skilling people, right? Which also helped us improve our throughput. So in the first thing that we did, which is just work in progress throttling, um, it didn't really have an effect on our throughput, right? The in an iteration, the amount of work that we are producing is still the same. So is it just the optics of the lead time that are getting improved by doing that, or is there some other added benefit as well?
Right. So there's several ways to look at this. Typically, in the traditional way, we say this project has to be done, and these are the things that have to be done. This is a fixed set. If it is a fixed set and you just have to execute it, then it doesn't really matter what you do. Lead time is not that important. What is important is the cost of the project and so on. If, however, you say this is what we think we need, and every time we finish one thing, we feed back on that, and we think of new things to do, and we also eliminate things we thought we needed, but we don't need because we realize that is important, then the lead time is important because the feedback loop is there. So I make one thing, I finish it. Once it's finished, I take that feedback and I reevaluate the list of tasks I have to do. And so this thing becomes scope that can change with the new knowledge you're acquiring. And so at the end of the project, you know the most about the project. At the beginning of the project, you're the dumbest you can be. And that's the moment traditionally you have to decide what goes into the list. And so it's more the agile mindset that says you have to continuously reevaluate your backlog. And so it's important to know to lower your feedback cycle and so improve your lead times. Does that answer the question?
Yeah, and I do have a slightly related follow-up question as well. So when I asked on the chat, right, are we considering to do as part of work in progress? And you said the larger the scope, the more optimal our analysis of the whole cycle would be. So typically, when we are working for our clients, right, it's our clients who are creating the to-do. And as you said, in a traditional project, they start with a bunch of things that they think they want, and then they keep adding or removing things to it. So initially, when we start the project, we already have a huge list of to-dos, right? And if we count that as part of our work in progress, then wouldn't that give us incorrect understanding of the flow.
Again, thought about in the sense of the number of items to do is fixed in your current example. Is that right?
So
I'm not sure.
there's a lower limit to it, that when you start, you know at least these 100 things you need to do, and we may or may not add another 50 things on top of it.
I think it's both, right? It's even the 100 thing is more like a wish list. Sometimes nothing happen. Many things may not happen from those 100 things as well, right? So initial, I think what CI is saying is there is a initial list. Someone has imagined a system already, and that imagination is put down in an Excel sheet with items. Not 100% of it may happen. 70% of it may happen, 30 may not, and then more things may happen. So instead of 100, you may do 200 different things, and some of the things from the original list you may not do.
Okay, so I'm not sure what the question is then, or did you just answer the question?
I think though, I don't know, Michelle, the question that she has and the answer that you gave earlier were not correlated. So see what Michelle meant was that you improve the scope of the system to make the whole system better. So I don't know, Michelle, is the answer over here that works so closely with your customer so that they don't start with 100 items? I think what CI is saying is that if you're starting with 100 items and if we have to estimate it anyways, right? So what's the impact of limiting work in progress later, like just from analyze to done step, because to do is already there when we started.
So I'm going to refer back to here, for example, when I run this simulation, I only measure between UX and QA. So the backlog column and the done column is not included in this. So in that sense, because I'm only limiting between UX and QA, I'm only able to improve that part. And so it's really a question of what do I want to improve? If the system is the customer is going to ask for 100 things and there is no wriggle space there, you're not capable of improving that system, just don't do it at that moment. It's really a question of what is my intention? What is the thing I want to improve? And so depending on what your constraints are, you're going to say, this is the scope of what I want to improve. This is also the part that I'm going to measure and apply work in progress limits. I think in the chat, I'm not sure if I pronounced it right. Daval says has yes, exactly, a similar question.
I think another recurring question, Michelle, we get is that when we are trying to do WIP limit, there may be people who has nothing to do. Like there may be instances, and what do we do at that point of time? Do we let that person do nothing?
Okay, let's go to a post that is very old. One day in Kanban land. There it is. 2009. What do you think? This is a typical project, right? There's a backlog of things to do. There are WIP limits already on things. And so the product owner says, I'd like to have A and B done. The teams pair, of course, since we do XP practices. This pair says we'll do A, we'll do B. Product owner adds C and D. A is done. It comes in the A column. The deploy person says, okay, fine, we'll start doing this. And then a bit later, oh, there's a problem. Something, they don't get it deployed. And so here, the pair says, let's do D. Oh no, we can't because there is a 2 limit here. We cannot start doing D. What do? They go there. How can I help? There is something downstream blocked. Instead of starting something new, which will increase the work in progress, we go and help where the problem is. And so that team is also ready with something and they cannot do anything either because this 2 is still there. And say that they go and help too. And so everyone this is called swarming. We swarm to where the problem is. And even the product owner goes there, and the only thing they can do is like stop any interruptions and so on. And then all of a sudden it gets deployed, and then everything can move on again. And so notice they improved this number to 3 because they noticed 3 is better than a 2. This is kind of playing around with things, but that is the main thing. If you cannot do work because of a WIP limit, and you don't understand the WIP limits, you're going to say, this is stupid. I don't want to do this. I want to start something new. But if you understand the whole thing, you're going to say, okay, I'm going to help where the bottleneck is. This might be downstream, but this might be upstream too. And by going to help, you are cross-skilling. You are improving your skill in that part that you don't know. And you're investing in new knowledge in something that tends to be a bottleneck. And so it's really about learning to collaborate more. There are other practices that improve this even more, and that's things like ensemble, mob programming, where you do everything together and there is never waiting time for tasks. Once you take something, it's always work on that task until it's done, which improves cross-skilling, which improves quality of things. But this is not a presentation about that, but it's a way to solve this problem too. If you really have nothing to do, you might go and improve, for example, the build time with 5 milliseconds, things like that. So improve something about the process, or go and get rid of some legacy technical debts, things like that, that improve the process. And I interrupted Sapan. You were going to say something, right?
This sounds no, you're right, and you mentioned swarming and you mentioned mob programming, and that's something that we have been trying to do internally as well. But then questions which are exactly opposite of this. So we were saying, what if there's a big set of things that keeping us busy? So we are saying, okay, let's all of us work on big thing. But then the opposite question is, we have small things to do. How can we have like, hey, I'm just cleaning something up. Why should I have, you know, let there be more work for other people. I'm just cleaning up a database table or something like that. And why do we need to mob or even parent for that matter?
Right. So the thing you have to watch out for if you have nothing to do and you say, I'm going to clean something up, is that if something appears in your inbox, you don't say, no, wait, I'm cleaning this up, because then you're again limiting things in your system. There's a small remark here in the chat that I like very much. So if something stays between analysis and development for too long, it tends to need analyzing, which improves again the work spent on that item, which is true because things changed while it was waiting in that column, and you have to reanalyze things. So absolutely. And they become stale and so on and so on and so on. Yes. So improving, if you read, for example, Accelerate, where they have like deployment frequency has to be improved, lead time has to be improved, you automatically get all those benefits.
So I think you did mention you shouldn't, I mean, if I'm doing a small work, if someone's available, I think I want to put a few thoughts I kind of in a structured way. So what we said is that there may be times when people actually are available and have nothing to do. So one option is, of course, help others move faster. Or you could do something like increase developer productivity by working on, let's say, build time, which increases or decreases the build time and increases the productivity. But even if it was cleaning up, don't do something that creates a queue for someone else, right? That should also be part of it. So if I'm working on something and now it has to be QA'd, so I did something to keep myself busy, but I increased either it went as a PR or something happened, so it again increased the queue. So we are okay. Makes sense.
Yep, absolutely. We're in agreement.
Makes sense. Thank you.
Right. Any other questions?
Just a follow-up to what Sapan asked. So I had the same question and I had asked Sapan, and he always mentioned that we could swarm on that particular lane that is blocked or that has the bottleneck. So even for that, I mean, we'll still need folks who are cross-skilled, right? So cross-skilling it would be something that is never a bad thing. Can we take that like as a takeaway from this? If let's say someone has some downtime, they can always cross-skill, and let's say if they are a dev, they can help with QA or they can help with deployments and stuff like that.
So your sound was not really that good, but I heard, is cross-skilling always a good thing? Is that right? So as far as I'm concerned, yes, on a personal level, of course, you want to learn all the time as much as possible, especially in our industry. On a flow perspective, if you're in the bottleneck, you don't need the cross-skilling part because you are the skill everyone needs to have. But of course, on a personal level, you want to improve your skills all the time, certainly. So in a generic way, I would say, yes, cross-skilling is something you should be continuously investing in. But on the flow part, only if you're not in the bottleneck, right? But me personally, even if I'm in the bottleneck, I'm going to try to invest in my own skill sets to improve continuously, because your worth improves, you're more valuable to the company and so on. And as a side thing, I work at a company where we invest in raising the level of everyone. So we do workshops about test-driven development, refactoring, improving designs, collaboration, things like that. And that is something we take like almost an afternoon, every 2 weeks to do workshops like that, because we know it will improve the speeds and the quality of the whole company. There are some more chats. I see Josefa wants to say something.
Yeah, let me take it in chronological order.
Okay.
So I think first is Rushali's question over here that says, isn't there also a psychological aspect to limiting WIP that may help person complete their tasks slightly faster just because they are more comfortable and calm compared to when they had work pile up? Not only that, I think there's one more thing, which is they may be doing lesser context switching as well. So if you're working on one thing at a time. So is there any comment on that, Michel?
Oh, yes, absolutely. So let's take the scenario. I'm a developer. I'm working on a task, and it was estimated as 3 story points. Let's say something like that. And my product owner calculated this means it should take about 4 days. And I'm already working on it for 5 days. My personal reflex, or the probability of me saying I have to hurry, is high. And so if I have to hurry, I think less clearly, and I'm going to not worry too much about quality, refactoring, making something clear for the next person who is going to pick it up, which makes that piece of code harder to change later on. So I'm going to cut some corners today to be a bit faster, but in the long run, I will slow the whole project down. That's the effect of one story feeling like I'm not going fast enough. If, however, I have a backlog of 50 things I have to finish by the week, of course, I'm going to have to cut corners and hurry to finish it at the cost of future work. So there's a term for it which escapes me right now, the marginal cost. So every story you finish will raise the cost of the future stories you have to make. The thing is to limit that as much as possible. And every design you choose today is actually a bet for the future, or so don't make things too hard. Don't keep it very simple as much as possible so it can change in the future. And but that gets completely into the XP simple design kind of things, which is completely out of scope of this presentation. But it's true that on a psychological level, having a big workload before you will lower your quality, and which is actually one of my takeaways, I think. There you go. Quality goes down because of this.
Right. And we have a question by Sia, but I would let Sia will wait for a few minutes. I want to keep an eye on time as well. And Huzefa hasn't asked a question so far. So let's, Huzefa, please go ahead.
Yeah, so I just wanted to ask that how do you go about measuring lead times for a team? So if you're whenever you're doing an iterative development, like let's just say, for example, we have a 2 week sprint, and how would you go about measuring that? And then maybe we can talk about how we can try to limit or reduce that.
So if you measure just one thing, it's when do you start on something and when is it finished? These 2 dates, that's it. If you have these 2 dates, that's enough to measure lead times, which is just the difference between these 2 dates. And throughput, the same thing, the end date. If you have 3 things that have been finished on one day, then your throughput is 3 per day, right? Or 3 on that day, and you take average from that too. If you want to go more into detail, like this cumulative flow diagram that we have here and that we had here too, right? Cumulative flow diagram, which doesn't represent anything here because everything's flat. Then you need dates every time you change column.
Yeah,
and that is more involved. I've been on a project where we did that on paper with just cards on a physical board, and every time we changed, we wrote the date on it. And since there were only 4 or 5 columns, that was perfectly manageable. And then someone has to enter that in a spreadsheet or whatever tool there is to do these calculation things. Some boards, typically Kanban boards, do that automatically. Jira is very bad at it. It's sometimes even wrong about it. So you could try to do that with Jira. I have no idea what tool you have. I kind of prefer the manual part because you understand the system, while Jira is just, it's a report, but we don't really know how it came about.
Yep. Just a follow-up question.
So actually, Huzefa, I would like to limit questions because I have one from Dhaval. How about you also send it in chat? So if someone has the same question, answer to the question, may answer it, or we'll take it because we want to, Michel, if possible, wrap up the call in 8 minutes. So I have one question from Dhaval, one question from either Sia or Huzefa, one of them can ask, and if we have time, the third question, right? So I think Dhaval has asked the question over here that says, isn't working on a something like helping faster build, which is not on the board, is hidden task in itself. As such, it may impact hiding actual inefficiencies in the flow.
So you mean if you have nothing to do, you pick up something small to do? Is that the question?
I think so. Yes, I think, yeah, in a way, what it is saying is that if I pick something up to do and if I created a card for it, wouldn't that offset the change, right?
Yes. So let's look at this one. Did these people add a card to the board? And the answer is no, they helped something else, or they might have improved a process that is not related to the bottleneck. But the key is, if you're not influencing the board, don't overload it with more things, because this is indeed going to have some inception kind of feedback loops where you're going to try to improve the work that you did while you were not while you were out of work. I wouldn't do it, but I would limit it to very, very small things that you can interrupt at any moment. Once you start creating tasks because you have too much time, that is when there's going to be wrong feedback loops in the system. So try to limit that to very simple things and keep as much as possible in touch with your teammates, what you're doing, so that anyone can point out, this is not effective what you're doing right now.
So I'm going to kind of interject my question in this. The answer that you give, Michel, is of a company that's not enterprisey, so to speak, right? So there are companies which needs a ticket for someone to even commit or push code, right? And that, I think that's where the question may be coming from as well, that, hey, even in order for me to push a ticket, I mean, to push code, I need a ticket ID. So how do you, I think these are just complicated systems.
Yes, and they are systems that are going to, by design, slow down your development. This is something I wouldn't advise. So having work without a ticket is perfectly okay if you have the discipline to keep it small and to not influence the actual work that needs to be done. But there's those constraints, like you cannot commit anything without a ticket number, is more a constraint that is going to slow your project down. I wouldn't do that.
Right.
I've seen it happen, and I've always worked against that kind of systems.
Now, Sia, before we come to your question, I'll still go ahead and ask you the first follow-up question, because it looks the answer may be shorter. When would you consider optimizing for lead time versus optimizing for throughput? Or you cannot do one without the other?
So throughput is important when you're on cruise control. When you are discovering which direction you need to go, you're more based on feedback loops, then lead time is more important. Sometimes you have to choose between both. Sometimes improving lead time is going to lower throughput and vice versa. That's really a question of how much do you need your feedback. If you know what you're going to do, like the original question, I have a fixed set of things that have to be done, then by all means, lead time is not important. I think lead time is still important because you're going to have upstream is going to have an effect downstream. And sometimes a certain wording in analysis can double or triple the work in development because of misinterpretation. Still there, you need small feedback loops. But on a wider scale, it's a fixed number of things to do. Lead time is less important. I think it's still very important that we don't realize it because, for example, in Scrum, we don't measure it, right? We measure velocity, and that's the only thing we measure. But there's some instances where lead time and throughput are trade-offs you have to choose between. And that's actually a business question.
Sia, do you want to go ahead and ask your question?
Yeah, sure, Sapan. So in our team, Michel, we have 3 roles primarily. We have the product analyst, we have the developers, and we have QA. And it's much easier for developers to go in and help PA or QA if need be, if that's where the bottleneck is. But the other way around would be much more difficult because those would require technical skills, understanding languages and frameworks and existing code base, right? So, and the problem here is that typically in our team, the bottleneck is on developers. So what would you suggest? Is cross skilling a real option here, or do we have other alternatives?
There's only 2 things that are in scope of this presentation, and that's adding people, of course. And if you really, really know that the bottleneck is development, then adding developers will help. However, there's a limit to that because developers have to communicate amongst each other, and the lines of communication also explode if you add too many people. So adding people is going to help in the medium term, not in the short term, because they have like to learn the system, learn the landscape of wherever your context is. But it's going to improve. If you have a bottleneck and you know it's the real bottleneck, then adding people is going to help, but it's an expensive one. Cross-skilling is going to help. You have to realize that if you have a bottleneck that is working at 100%, and you can have someone that has some free time improving that and making it 101%, your whole system is going to go 1% faster. And so even then, cross-skilling is going to help. But in the short term, if you're going to have a tester or an analyst doing development, you're going to go slower because there's like, you have to learn so many things and you're going to use time from the actual developers who are already full-time busy. So it's going to be an experiment depending on your given context, if it's going to work. I tend to always invest in people that are not technical to at least understand and being able to talk with people who are technical. Because sometimes, and that then you have to look at yourself. I'm a technical person too. I program every day. I am intuitively drawn to complexity, which slows me down in the long term. And that we need to learn to push this complexity away, because this is a self-imposed thing. And sometimes external people looking at the same problem will trigger ideas, and it will even make you question your decisions, which might speed you up too. But this is very fluffy. It might be there. There's a probability, but it's not always the case. So I don't have a silver bullet for you. The easy way is add developers, and let's not talk about the rest. But cross-skilling is, to me, always valuable. Of course, they have to be willing. I've met people who say, no. I'm an iOS developer. Don't show me HTML. Don't show me a database. Don't show me any security things. I just want to do iOS development. Okay, fine. If that's what your choice, but do realize that this lowers your value to the company. That's a given for me. Of course, there's like a shortage of mobile developers, and then of course it's not true today, but it might be true in the future.
I think, Michel, there's one more thing before we close, because I always like to say this. One of the things that the underlying question that SIA has is not just QA and developer, but I think when this question was asked, coding was seen to be a primary activity. Software writing code, not even, I don't even want to use the word, writing code is seen to be the primary activity. And that's why we think that, hey, how hard will it be to, cross-skill QA to writing code? But software development and developers' job may actually go a lot outside of just writing code as well. And maybe that's where we do a little bit of cross-skilling. I don't know where every person's outside of, but I know for sure that some developers go and ask for requirements. Is there somewhere where we could pair or get QA's help, right? So I think we have to break down and start looking at software development from a different lens and not just necessarily coding. And then we may find better options as well.
Mm-hmm.
And
right.
I think Purushottam has one last question, but I think we have to keep it. We're crossed 1.5 hour mark now. The last question that Purushottam has is quite curious about the simulator swim lanes. Is there a proportionate time set for each task to move from one team to another? Example, analyst may take 8 hours. The expected solution dev may take 24. QA may take 16. Is there any standard formula to come up with estimates for each team swim lane? How much time they would take? Or it'll need to be done case by case during the sprint planning?
I'm a bit confused about the term swim lanes. So swim lanes to me is horizontal, and I have a feeling this is meant vertically, the columns.
Yeah, it was.
I think we call, yeah.
Okay, right. So
So in short, my question is related to for these 3 to 4 roles to be in better sync with each other, because we have always been hearing that, hey, developers are bottleneck, but they may not be in a way, because we are always asking them to come up with the story points during that planning poker. But I haven't seen anyone asking an analyst or a QA to come up with the same method and to come up with the story points for them to test something or for them to write an functional specification document. So can we use that same methodology for each role so that we can kind of fine tune the same task between all the 4 roles and to make it to the done status?
this is going in the opposite direction of what I would advise. I would advise not to estimate anymore, but to cut tasks to be as small as possible, so we can learn by doing that, just counting the stories, not estimating them, because the wait times are always very unpredictable. You do not know what is going to happen during sprints, especially if you're in the continuous delivery world where you're pushing to production multiple times a day. You don't know which issues are going to come back from production and are going to stop your flow. The bigger the work you're going to batch into one thing, the bigger the chance your quality is going to go down, and that you won't have any feedback loops inside that part. So this is going very, very outside of the scope of the current presentation. What I can give to you is story points at development level only are very, very inaccurate. Just try and get statistics from your current ticket or storyboards. If you use Jira, for example, you'll see that story points compared to the actual time it took from starting to finish is widely inaccurate. So the dream of developer have to give story points, so let's make QA and analysis also give kind of points, is completely useless as far as I'm concerned. It might work because you will get numbers and you will be able to add them and average them, but the outcome is not going to be anywhere close to the real world. So I haven't answered your question because I don't agree with the premise of the question. So sorry about that.
I think
That's okay. Yeah.
I think Sia sums it up really well. She has said it in the chat that day by day I'm starting to believe that estimating is essentially lying. They're going to be wrong all the time. Anyways, great. Thanks a lot. That being said, Michel, thanks a lot. And thanks a lot for giving us way more time than committed. I really appreciate it. And to close it, we have a talk by Dragan on 13th September. All the people from India and Belgium are welcome to join. We'll share an update. Perfect. Thanks. And hoping to see you all soon. Thank you.
So Dragan is absolutely recommended. Very good speaker.
Great. Thank you.
Right.